All right, guys. We are going to continue our learning and target E2, EI.2, our notes on linear and absolute value inequalities. Today, we are going to take a look at compound inequalities, extending from what we learned on solving inequalities in the last video. And then we're going to go ahead and take a look at some application problems. So let's start with kind of some basic notational things that we're going to see that's new for compound inequalities. So far in the notes, we actually did experience some of these notation, and I told you I'd expand on that. It is the symbols for union and intersection. So you can see here at the top of the screen that the upside down U symbol, the U symbol here means union. That is telling us that we are including all of the elements in one set or a different set. So it's an element that could be included in one of two sets or potentially even in both of two sets. The upside down U is what we call an intersection. And this is when we're looking for elements that are in both sets. So we have like two different groups and any element that is associated with both of those two groups. The union is what we talked about in the previous video as relating to the word or. And the intersection is what we talked about as relating to the word and. So if we want to look for keywords that describe a union or clue us in on a union or an intersection, or would mean union, and would mean intersection. So let's take a look at an example of how that works. When we start to look for a union and an intersection, we take a look at problem 3 here in the notes. Problem 3 says for set A, and it gives us some values that are in it, and set B, and it gives us some values that exist in set B. Determine the intersection of A and B and the union of A and B. So the intersection, that first symbol we see there again, that is the upside down U. If we want the intersection of A and B here, we're going to be looking for any of the elements that are in both A and B. So in this case, it's referring to numbers. So the intersection of A and B, we can see -2, -1, 0 all lie in set A, but they're not in set B. So they cannot be in the intersection. 1, 2, and 3 are in A, and 1, 2, and 3 are also in B, so we can include 1, 2, and 3 as our values here in the intersection of A and B. If I look at numbers 4 and 5, number 4 and 5 are part of set B, but not part of set A, so they are not included in the intersection. So the intersection is looking for values that are in both of those two sets. The union is looking for values that are in one or the other, and potentially both. So if we look at set A, we would have -2, -1, 0, 1, 2, 3. Those are all included in set A. But in addition to that, we have some numbers that are included in set B. Those would be 4 and 5. So if an element shows up twice, like 1, 2, and 3 did, we only write it down in the union once. We don't have to rewrite that again multiple times, but it's going to be included in the union as it is part of both of the sets, which still counts as being in one or the other. Now, we can use this concept to help us solve compound inequalities. So if we take a look at problem number 4 is like problem number 2, where we are going to solve the inequality, and we are going to put it in graphical representation and interval notation. So what we see in 4a is it describes the two equations with the word or. So what we're looking for here then, the word or relates to a union. It's going to be a solution to the first equation or a solution to the second equation. So what we can do here is we can write this out as -3 minus 1 is less than or equal to is less than 4, -4, and then replace the word or with a union. And now we can solve this like we would any linear inequality. So with my first one, I'm going to work over here on the left first. I'm going to add 1, so -3x is less than -3. I'm going to divide by -3. Remember, when we divide by a negative number, we have to flip the sign, so x is greater than 1. Then I'm going to solve the other equation as well, so I'm going to subtract 3 from both sides. So 4x is less than a -9. I'm going to divide by 4, so x is less than -9/4. And again, this is the union of these two. So if we want to graph this, when it comes time to graph, we want to make sure on our number line the negative number, or the lower number, -9/4, is to the left. So -9/4 is here. 1 is to the right. We're looking for anything that's greater than 1. So an open circle at 1 because it's not equal there, and then shading to the right of 1. Then for -9/4, an open circle there and shading to the left of -9/4. So what this is telling us is we're looking for anything left of -9/4 or less than -9/4, and anything greater than 1, sorry, or anything greater than 1, a number that is going to be the right of 1 on the number line. If we want to check this, we could see if some specific numbers work. So let's try the number 2. The number 2 is greater than 1, so it would exist in this shaded region. So if I go back to my original equations, I'm going to put in 2 for x. And that does satisfy this first part. So it would say -7 is less than -4. That would work. And I'm going to put in 2 for x in the second part. Now, this one would say that 11 is less than -6, but that's where that word or comes in handy. X works for the equation to the left, but doesn't work for the equation to the right. So our answer is still a good answer. Sorry, 2 works for the equation to the left, but doesn't work to the equation to the right. 2 is still a viable answer for x. It's just going to satisfy one condition, which is okay because we see that word or. So now as we put this into interval notation, remember interval notation, we start the furthest left on the number line here in the graph, which would be -infinity, and we're going to -9/4. It does not equal at -9/4, so we put a parenthesis there. We're going to use our union symbol, and it picks up again at 1. It's not equal at 1, but then it does go to positive infinity. So these 3 representations of the same answer would show us values for x that would satisfy one of the equations or the other equation. Let's take a look at B. Notice that we see the word and here. So this time I'm going to go ahead and just start the solving process from the beginning. I'm going to solve the problem to the left. So subtract 5 first. So 3x is greater than -18. And divide by 3. So x is greater than -6. Going to do the same thing to the right. So subtract 5 on both sides. So 3x is less than -6. Divide by 3. X is less than -2. So in this case, it's an and. So we want to use the union symbol here. So we're looking for numbers that are greater than -6 and less than -2. So on our number line, I would put -6 here, put -2 there. It is an open circle. So we would be looking for things that are greater than -6, so to the right of -6, but also left of -2 because less than -2. So this shaded region here between -6 and -2 would be our solution set. So now we can write our interval. X is from -6 to -2. Using parentheses here, not brackets, because it is not equal. Now, compound inequalities with an and can also be written occasionally in a single expression. And that's what we see in part C. So in part C, basically what this says is 2x plus 5 over -3 is less than 1, and 2x plus 5 over -3 is greater than or equal to -6. So now we have basically the same concept that we had in 4b, but instead of writing it as two different equations, it's written as a single equation because there's only one expression that it contains the x. Now, when we solve this, there are basically three parts to the equation. Normally, or inequality. Normally with an equation, let's go back to 4b, I subtracted 5 on one side, so I subtracted 5 on the other. I divided by 3 on one side, so I divided by 3 on the other. With this type of equation, if I make a change to the middle here to get x by itself, then I need to make the changes to the outside, okay? So I've got a fraction here. I need to get rid of this fraction, so I'm going to go ahead and multiply by -3. If I multiply the inside by -3, I need to multiply everything by -3. So we need to move this or get rid of this fraction in order to work with the x in the numerator. So I'm going to multiply the entire thing by -3. That's going to get rid of the fraction. So one times -3 would give us -3. Now we have to be careful here because remember, we're multiplying by a negative. So when I multiply by a negative, my sign is going to change. So now that greater than symbol becomes a less than symbol. 2x plus 5 over -3 times -3. The -3's would cancel out, so we just have 2x plus 5. Remember, I'm going to have to switch this symbol as well. -6 times -3 would give me a positive 18. Now I can continue to solve. I'm going to subtract 5. And again, making sure that I subtract 5 from all parts, not just one side and the other of the inequality, but if I subtract it from this middle term or this middle expression, I have to subtract it as well from both right and left of the inequality symbols. So this is going to give me -8 is less than 2x is less than or equal to 13. And finally, I can go ahead and divide by 2, again, making sure I'm dividing by 2 on all parts of this expression. So -4 is less than x, which is less than or equal to, I'll just leave this as 13 over 2. If you made it 6.5 or 6.5, that would be okay as well. So this is the solution set for my value for x. So now if I graph this, here's -4. It's not going to be equal, so empty circle at -4. Here's 13 over 2. It is equal at 13 over 2, so close circle over 13 over 2. It's going to be all of the values in betweens. So this is, again, technically an AND statement. Then my interval would exist from -4 with a parenthesis to 13 over 2 with a bracket because we are equal at 13 over 2 and not equal at -4. So again, there are three representations for these solutions. So solving a compound inequality is the same concept as solving a linear inequality in terms of the steps that we take. What we do have to be careful of is when we're selecting our answer set or our group of answers that our group of numbers our answers could come from, that we're taking into account whether this is an or, a union, or if it's an and, an intersection. Now, let's go ahead and let's take a look at a couple word problems. See how we can apply inequalities. In problem number 5, it says Justin earned scores of 78, 72, and 86 on the first 3 out of 4 quizzes in Algebra 2. What score must he earn on the fourth to have an average of at least 80? So, Justin here, we know, has a 78, 72, and 86 on 3 quizzes, and then he's going to take a 4th quiz. So remember, when you're finding average, when you find average of scores, you take all the scores, you add them together, and you divide by the number of scores you're adding together. So those are his first 3 quiz scores that we added together. We do not know what he's scoring on the last exam. So let's make that one a variable. Let's make it x. There are 4 total scores there, so to find the average, we're going to divide by 4. So 78 plus 72 plus 86 divided by 3 would be his current average. But then if we want to find out what his average is going to be, or could be after the 4th one, we want to make sure we add an x in that numerator and now divide by the 4 terms of the numerator. It says, what score must he earn on the 4th quiz to have an average of at least 80? So what that tells me, that word at least tells me we want 80 or more. So we want his average to be greater than or equal to 80. So this is an equation that's going to represent an inequality that's going to represent the solving process that could figure out what he needs to score on the final test. So what we want to do here is we want to go ahead and simplify this equation in the numerator. So we can take 78 plus 72 plus 86, and we can add those together. And this is 236 over 4, which is, 236 plus x over 4, which is greater than or equal to 80. And now we can go ahead and multiply by 4 on both sides to get rid of our fraction. So 236 plus x is greater than or equal to 320. And then we can subtract. I'm not going to write the step out. I'll just do it in the calculator. So 320 minus 236. And then x is greater than or equal to 84. So if we want to put some context then into his answer, he needs to score 84 or greater. So if he scores an 84, his average will be exactly 80 for the year. If he scores higher than an 84, then his average will be above 80 for the year. Go ahead and take a look at another example. This one's a little bit more complicated. Problem number 6, it says, as Margaret starts her new job, her employer offers 2 salary options. Plan 1 is a base of $1,475 per month plus 3% of sales. Plan 2 is a base pay of $500 per month plus 15% of sales. What level of monthly sales is needed for her to earn more under Plan 1? So before I even started writing equations here, let's say we want to we want to earn more under Plan 2. So what we want is for Plan 2 to be greater than Plan 1. So let's figure out what Plan 2 is going to represent. So this is $500 a month plus 15% of sales. So we know that initially she's going to make $500 no matter what. Depending on how much Margaret sells, then her salary would increase. So remember, 15% would be 0.15. We don't know what the sales are, so let's just make that S. So her salary under Plan 2 is going to be 500 plus 15% times S, or 0.15 S. We want that to be greater than Plan 1. So Plan 1 has 1,475 per month plus 3% of sales. So 0.03 times S. Now, we can simplify this equation. So what I would want to do here is get the s's to the same side. So subtract 0.03s. And what that's going to give me is 0.12s. Remember, I do not have to change my inequality symbol here because I'm not dividing by a negative. I'm subtracting here. Then I'm going to subtract 500 from both sides. So I'll get 0.12s equals 975. Now I want to go ahead and get S by itself, so I need to divide by 0.12. So S is going to be greater than still, because I'm not dividing by a negative. S is going to be greater than 117. Sorry, that's not right. I must have typed something in. Oh, there we go. 975 divided by 0.12. My apologies. 975 divided by 0.12. So S should be greater than 8,125. So the question is, what level of monthly sales is needed for her to earn more under Plan 2? So she needs 8,000, more than, it's a greater symbol. So we don't want equal, we want to earn more. So more than or above or greater than $8,125 in sales. So anything above that number would allow her to earn more under Plan 2. So here we have two examples in problem 5 and 6 of solving linear inequalities. Notice that the first thing I did was read through those problems. Then went back and looked at what is the question asking me. Then went back and picked out the important information so that I could put that into an equation that I could then solve to answer the question. This is where we are going to stop for part 2 of the EI.2 notes. When we return to class on Tuesday, we will go over any questions that we have on EI.2 notes problems 1 through 6, and then we'll have the rest of the time to begin working on the homework. Your homework, again, is going to be due on October 1st, so it might be a good idea to get a head started on it over the longer weekend if you have the chance. Thank you guys for tuning in.